Hello, in this video we're going to be continuing our discussion on section 5.1, solving systems of equations by graphing. Our essential question for this section is, how do you solve a system of equations by graphing? What does a solution represent? So as a reminder, in our first two videos on this section, we solved a linear equation by graphing. All that we did is we took our equation, we identified the slope, in this case it is m, and the y-intercept, in this case it is -8, and we use that to graph our line. So I go down to a y-intercept of -8, 1, 2, 3, 4, 5, 6, 7, 8, and I put my point. My slope is 2, or 2 over 1, so I go up 2, right 1, up 2, right 1, until I run out of graph. Remember that we do want our line to be as accurate as possible, so we put as many points as possible. We can also go down to left 1. So these are all the points for my line, and I will connect them to draw my line. So my line will look something like this. For my next line, which I will draw in red, my slope is a -2 over 3, and my b is whatever numbers are added to the outside, but in this case there's nothing. So in math I call nothing 0, meaning my b value is 0. So my y-intercept is here at the origin. My slope is -2 over 3, so down 2, right 3, down 2, right 3. And since I have an intersection, these two lines cross, I know that these are the only points I'm going to need, so I'll go ahead and graph my line. I now look for the point of intersection, which is this point right here. It has the coordinates of 3 for x and -2 for y, which means that if I put a 3 in for both of the x's in my equations, I will get out a -2 for both of the y's in my equation. So I'm going to go ahead and try this out and make sure that I found the correct point. So I'm going to try what happens when x equals 3. So y equals 2 times 3 minus 8, or 6 minus 8, which is a -2. So that gives me the ordered pair 3, -2, which is, sure enough, the ordered pair that I have as my solution. To check my second one, I'm going to plug in an x value of 3, and I'm hoping to get a y of -2. So y is -2 over 3 multiplied by 3. Or we can write this as 3 over 1. So y is equal to -2 times 3 is -6. 3 times 1 is 3. And -6 divided by 3 is -2. So sure enough, when I put in a positive 3 for x, I get out a -2 for y. This is the only point that's going to work because this is the only point that the two lines have in common. There is no other point where I will put in the same x value, in this case that x value was 3, and get out the same y value. In our next example, we have two equations in standard form, and we're going to complete the process exactly the same as we did before, except that we need to find a way to graph from standard form. I'm going to ask you to take a moment to pause the video and recall graphing from standard form on your own, and then identifying where the two lines cross. Okay, so equation 1 I will do in blue as usual. I've got 2x plus y is equal to 5. If I want y alone, I need to subtract my 2x from both sides. So I have a positive y is equal to, and I want the x first, so I'm going to have a -2x. 5 is positive, so then I have a plus 5. In equation number 2, I will do this one in red. I've got 3x minus 2y is equal to 4. So I want to get the negative 2y alone first, which means I subtract 3x from both sides. I have a negative 2y is equal to, and then I want my x first, so negative 3x plus 4. And then my next and last step is to divide everything by negative 2. That isolates my y, so y is equal to negative 3 and negative 2. Two negatives divide to give me positive 3 over 2 times x. Positive 4 and negative 2 divide to give me a negative 2. So now I have my two equations in slope-intercept form. My y-intercept b here is 5, and in my first equation my slope is a negative 2, or a negative 2 over 1. So b is positive 5, and slope is down to right 1, as far as I can go to make sure my graph is as accurate as possible. I can also move that negative to the bottom and have a positive 2 and a negative 1, or up to left 1, as far as I can go. So now I can draw my line. And my line looks like this. For my second equation, I have a y-intercept, or a b value, of negative 2. And my slope, m, is a positive 3 over 2. So I go down to negative 2, and then up 3, right 2, up 3, right 2. And I see that if I draw my line, it is going to cross my other line. So I don't need to worry about putting any more points on my graph, because I have enough to see where they cross. So my two lines cross at this point right here, which is where x is 2 and y is 1. Meaning if I put in an x value of 2, I will get out a y value of 1 for both equations. So my solution to 1 is the point where the two lines cross. All right, your turn. Go ahead and take a moment to pause the video and solve these two systems of equations on your own. Right, in my first system of equations, I solved for y to get y equals 5 over 4x minus 2. And in my second equation, I get y equals 1/2 x minus 2. And identifying the point of intersection, I see that they cross here at the y-intercept, where x is 0 and y is negative 2. So the point where the two lines cross is 0, negative 2. In my second system, I solve for y in my first equation to get y is 4x minus 2. In my second equation, I get y is x plus 1. So the two lines cross here at the point where x is 1 and y is 2. We're going to move on into some application questions. So in order to solve these questions, I need to first write an equation, and then I'll see what I need to do to answer my question after I've written the equations. So you have a total of 18 math and science exercises for homework. You have 6 more math than science exercises. How many exercises do you have in each subject? Okay, so they want to know how many exercises in each subject. Well, the subjects that I'm talking about are math and science. So I'm going to go ahead and let math be x, and I'm going to let science be y. So step 1, assign variables. I have 2 variables, which means I need 2 relationships. So 2 variables means I need to write 2 equations using 2 different relationships that are given to me in my question. So the first relationship I see between math and science is that there is a total of 18 math and science exercises. So this tells me that if I take my math questions and my science questions, I've got some for math, some for science. If I add the number of questions up, I will get 18. So this tells me that x, my math questions, plus y, my science questions, is 18. The second relationship I see is you have 6 more math than science. So this is telling me that my math questions, they are more than my science questions. So I'm going to start by saying my math and my science are equal. But what they're telling me is that math is 6 more than science. So math is or equals science plus 6. So maybe I have 12 questions in science, then I would have 18 questions in math. Maybe I have 5 questions in science, then I would have 11 questions in math. Maybe I have 1 question in science, then I would have 7 questions in math. So math is more than science by 6. So x is equal to y plus 6. So I have my 2 relationships or my 2 equations. Now I need to solve for x and y, and I'm going to do that by graphing. So in equation 1, I'll just subtract x from both sides. So y is negative x plus 18. And to get y by itself in my second equation, I will subtract 6 from both sides. So x minus 6 is equal to y, or y is equal to x minus 6. So in my first equation, my b is a positive 18, and my slope here is a negative or negative 1, which is negative 1 over 1. So I'm going to count by 2's. I've got 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. So I'm going to start here at 18. And then I go down 1, right 1, 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 down 1, right 1. So I see this pattern. I'm going to go ahead and continue this pattern all the way as far as I need to go. I know I'm not going to have a negative number of questions, so I'm just going to draw my graph using the dots that I've shown here. My next graph has a b value of negative 6, and my coefficient on x is 1, so my slope here is a positive 1 or positive 1 over 1. So I go down to negative 6, here's 2, 4, 6, and then up 1, right 1, up 1, right 1, up 1, right 1, until I get a point where they cross, and that would be here. So I go ahead and draw my line. So the point where the 2 lines cross is here, where my x value is 2, 4, 6, 8, 10, 12, and my y value is 2, 4, 6. So that means that x is 12, y is 6, but x is math, so there are 12 math questions, and there are 6 science questions. These 2 numbers do add up to 18 because we have a total of 18 questions, and my math questions, there are 6 more than there are for science, so we have answered our question. Go ahead and take a moment to pause the video and try these next 2 exercises on your own. You may want to remember for this first one that area is equal to length times width. That will help you get started on your first one. So my first step is to write my equation for area. I've got area equals length times width, or 4 times x plus 4, and then I simplify and let y be area. Similarly over here on the right, I've got area is 6x minus 6, and then I graph. I did need to count by 2's because my graphs don't intersect for a fairly long way. So I counted by 2's, and I found that my graphs are going to intersect at 5 and 24. They just ask us to solve the system. They don't ask us to interpret. So once we find that point of intersection, we are done. We'll go ahead and stop here for today. Thanks so much for watching.